So I think you should be able to see the slideshow now. So these are the programmers on our team. Uh, this is me, Nash. This is Anthony, Joey, and Matt Glasser. The he's a little silly, but yeah. Okay, so we not going to talk about like the basics of setting up Android Studio and all of how Java works, because you can pretty easily follow a lot of guides on that online. So this is our slideshow from last year, actually, because we were planning on doing it more interactive this year. But I'm just going to use this slideshow since there aren't as many people here. Oh, Nathan, what team are you from?
I'm from Scarsdale 12331.
Okay. So I just want to ask you a few questions about your programming so that we can figure out like what to talk about. So do you guys use like Android Studio?
Yeah, we do Android Studio.
And use Java, right?
Yeah.
And then like what sort of libraries do you use with Android Studio?
FTC lib, and then for like CV we use Easy Open CV, and we're looking to Limelight.
Okay. Looking to what?
Limelight, like the new camera.
Oh, okay. And then the FTC lib, it handles your like path planning and stuff, right?
Well, I don't really know. I don't work in that department, but like I'll just share whatever information you cover to my other programmers.
Oh, so you're not one of the programmers on the team?
I cover like more CV stuff in that area.
Okay. And okay, so we use a Roadrunner for the path planning. So I think FTC lib has like a different way to do that, but I'm not super familiar with that.
Yeah, I think we can use Roadrunner as well.
Okay. 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 So the first thing that I wanted to talk about was Kotlin. I think you might be interested in this. We switched to Kotlin last 2 years ago, and we found that it really helps in just making the coding experience more pleasant. So it was designed by JetBrains, which is also the company that makes Android Studio, and it's supposed to be a modern replacement for Java, but it's JVM compatible. So you can have one Java file, and you can have one Kotlin file, and they can import like functions from each other, and they can import like classes, and you can just call stuff from one to the other because they all compile down to the same JVM bytecode. So they're completely interoperable. You can like convert your code base like file by file and still have everything just work. But it's designed to be a little bit more modern, so it supports stuff like first-class functions. So in Java, when you want to have like a utility function, you can make a class and then put the function inside of there, right? So in Kotlin, you don't need to do that. You can just make a function at the top level, and you can also treat it like first-class object. So you can assign to different variables. You can pass it a function into another function, right? So that's if you're familiar with like in JavaScript, if you have like a map function or a reduce function, that all relies on you being able to pass a function into another function and like callbacks and stuff. So that's super helpful. And then there's also functional programming constructs, which is also makes your code a lot cleaner and nicer. It's also a lot more concise. So you have to type out a lot less, and it just does it's like smarter, so it can infer a lot of stuff like the types. So if you have a variable that's obviously an integer, like it's a number without a decimal point at the end, Kotlin knows that that's an integer. So you don't need to explicitly say that's an integer. And if you put like a decimal point in the middle, Kotlin knows that that's going to be like a double, I think, is the default one. And then if you put an F at the end, it's a float. But the default for any sort of decimal is a double. So it's so much easier to type out and quicker. And and simpler to like read, because it's does all that stuff for you. But that stuff wasn't the standard back then when Java was designed. So that's why Kotlin, they made the new language. So the syntax is a lot more concise. Specifically, like when you want to define like a function or like a class, you don't need to put like void. See, okay, it's been so long that I've typed Java, I forgot like the whole thing. But it's like void main function name, and it's like string args or something, right? If you don't, it's automatically infers the return type, and you can explicitly say it if you want to. And then when you make a class, right, in the constructor of the class, you don't need to say, take this argument and set it equal to this class like instance variable. Instead, if you just have it in the parameters, you can just mark it as an instance variable, and it will automatically assign it and set it up that way. And I can show you a little later in our code base how much nicer this looks. Another thing is null safety. So with Java, all variables are assumed to be the type that you said or null. So there's really no way to say this can be null or this can't be null and make a clear differentiation between the two types of variables. But with Kotlin, you have to explicitly declare a variable as possibly null if it can be null, with a question mark at the end of the type. And then it forces you to think about that and handle those cases explicitly. So that way you're not going to have these sort of errors when you think something is not null, and it'll like turn out to be null, and then you have an exception in your code, which is really bad during competition. Another thing that's cool is custom infix operators. So I can show you that also a little later, and you'll understand what I mean. But the same way that like plus, minus, multiply, divide, and all like the bitwise operators go in between two variables, you can also design write your own custom operators. So if you had like two vectors and you had a dot product and cross product, you could literally write name of variable A, the word cross, and you could put the the name of variable B. Or you could do name of variable A, the word dot, and then name of variable B. So it's really cool that you have those custom operators. So based on all of these reasons, Google actually recommends Java, recommends Kotlin over Java for making Android apps. If you just Google, look up on Google, the recommended way to make Android apps. Let me actually do that right now. So I'm not showing this out. Okay, never mind. But if you just Google, what is Google's recommended way of making Android apps? Google will explicitly tell you that Java is like the old way, and the better new way to make Android apps is Kotlin. And yeah, even if you don't know how to like code, it's actually an easier language than Java, I think, just because of all the modern changes and simplifications to the language. Even if you already know Java, you can easily learn Kotlin. And if you don't know any programming language, Kotlin is easier to learn. Okay, so this is like a few examples of the ways that Kotlin can be much easier to use. So, for example, like making variables, right? Instead of saying list integer explicitly, if you're using the list constructor, right, it's going to be a list. It's pretty obvious. So you don't need to explicitly say that. You can just do val numbers equals to list, right? And Kotlin can infer that for you. So also there's so many utility functions for like stuff like lists. So like a filter function, right? In Java, that doesn't exist. So what you would have to do is you'd have to do like a whole loop, and you'd have to like create like an intermediate like variable, and everything. Whereas in Kotlin, if you just use the filter function, and those brackets after it are just a lambda that's being passed into the function. So you don't have to actually include the parentheses. If there's just one function that's being passed in, you can just use the curly brackets in order to make the lambda. And then you don't even need to, if there's only one parameter to that lambda, you don't even need to declare the name of the parameter. It is just assumed to be the word it. So that's what that it is referring to. That's the item in that list that you are currently on. Another example would be making classes, right? So if you see on the left in Java, the way you would have to do it is you'd have to declare the name to be a private string, and then you'd have to build a constructor where you would take that string parameter and then assign it to the instance variable on the class. And then you'd have to also make a getter method that returns the name. Whereas in Kotlin, all that boilerplate is gone. So you can just say right after the class declaration that you want a name that is a string. And you can also say whether you want to be private. Actually, so it would be private val here, I think. But then Kotlin would also make the getter method. And then like if you wanted to have a setter method, it would also do that for you. And it would also like assign it to that instance variable. So you wouldn't need to like write all that boilerplate in your constructor. Some other stuff is just like more concise syntax. So here, make that bigger a little bit. Okay. So one sort of utility function that we have in our code is a class that wraps our gamepad. And what it does is it checks every time our event loop runs, or like not our event loop, but like just in our teleop, and we have a while loop, right? So every time that runs, we check whether like gamepad has just been pressed down. So there's some actions that we want to do while the gamepad's being held down, like a button, or some things that we want to do just on the key down event. So what we do is we check if the button has previously not been pressed, and then it changes state to being pressed. So and then we can look for that, and then we can also look for on the key released, and we can do like if it's been held for this amount of time, and like a bunch of stuff like that. So one thing that we have to do for that is we need to map. So what we did is we put an enum for each of the buttons, so that way we have autocomplete. So yeah, and then what we did is we have a really long switch statement to check which one we're looking at. But instead of a switch statement in Java, so the right side is Java here, what we have on the left side is Kotlin, and you can see how much shorter, cleaner, and simpler it is, how much nicer to read it is. So it just saves us so much time like that. And so the great thing about Kotlin is that it has all these benefits, but it's also super easy to set up. So if you want to add Kotlin to your code base, all you have to do is, I believe all you have to do is add these 2 lines here. So there is a build.common.gradle file where you can just apply the plugin Kotlin-Android. And then you'll also need to add it to your build.gradle as a dependency. And then your project should all be set up with Kotlin. It's been a couple years since we've set up Kotlin, but I believe these should be all the steps that you need. And then once you've done that, you're just going to need to like build your project again. So it'll download all the new dependencies and apply the plugin. And then when you you'll be able to make like Kotlin files, and your editor should all be set up with that. So you probably already have a lot of Java files that you've written, code that you've written in Java. So what you can do to convert all your existing code to Java is just press the shortcut Control-Alt-Shift-K, or you can right-click on a file in the File Explorer and click the Convert to Kotlin button. So Google makes this super, super easy in Android Studio. They have this automated conversion tool where if you just click that one button or that one shortcut, it'll go through all your Java code, analyze it, and then figure out how to convert it to Kotlin. Because Java and Kotlin are like so similar, with, fundamentally, they're all compiled to JVM, right? So it's really easy to statically analyze the Java and then make some Kotlin based on that. The only issue that we've ever ran into when converting Java to Kotlin is that sometimes some numbers in Java, if you write them without a decimal point, they will be automatically cast to a double or like a float if needed. Whereas Kotlin doesn't do that sort of automatic casting for correctness reasons, right? Just to prevent any sort of bugs that might happen with unintentionally casting, you might need to add, like if you had, think like something like a servo position or like a motor power has to be a double. And if you can just set those equal to 1 or 0, right, in Java, because those get automatically cast to a double. But in Kotlin, automatic casting does not occur. So you need to do 0 dot to actually explicitly say that that would be a double. That's like a really minor change. It'll put a red squiggly underline under all the places that you need to change that, make it super obvious. All you have to do is like add 1 period right after. So that's super easy. So yeah, I think we have a lot of other stuff to talk about as well, but show a little bit of what I mean by infix. Ooh. Hmm, how do I change which tab? There's something else here. Okay, so this is the Kotlin documentation website. It's really comprehensive and it really is very, very helpful. So I learned Java. This was like pretty much my only resource that I needed to learn Kotlin. I mean, not Java, right? So I already knew pretty much how to code. I just need to learn like the syntax and all the little quirks of Kotlin. And this website, documents it super well. It's just kotlinlang.org. It's the official documentation site. So the infix notation, you just define an infix function, and then you define it on the class that infix operator applies to. So if you have like an integer and you want to add a new function that you can run on integers, a new operation, then you just do it to the integer class. But if you want to do like a vector and you want to add like dot and cross products, was the example I was using earlier, right? You would just have your vector class and you would add that infix function to the class. So now you have an integer here and an integer here, and you have SHL as the operator word in between, right? The infix operator. So then it will just be calling that function essentially, but it's just really nice. So like some ways that this is used in Kotlin is like the until function is actually actually an infix operator. So it's similar to the range function in like Python. And then union and as. So as is not infix. Never mind. But union is like an infix for like sets. You can also do something like XOR and stuff like that. So very cool. I saw. Obviously, doesn't add any functionality, but it just goes to show how much Kotlin is really pleasant to work with. The notation and just the way you write it really appeals to me. Okay, so I'm going to go back to the slideshow, or actually, something I'm going to go, yeah, slideshow. So after, I'm going to go through the whole slideshow, and then I might show you some stuff in our code base as well. Let's see. Is that something else? So this is a little bit of an older video. It's from a couple years ago. But this is from when we first set up Roadrunner. See if I can play it. Okay.
Go. Yeah, just start it. Just start it.
Okay, so that was a little bit of an older video from a few years ago, and our motion planning has like improved. So we can do more complex paths than that now. But I just think it's really cool how you can turn and move in all sorts of complicated curves at the same time. And Roadrunner will just plan out all of that for you. Just if you just give it the start and the end point and sort of what direction you want to go in order to get there. It will use quintic splines, I believe, is the mathematical way it calculates it under the hood. So it'll use that in order to make sure that the acceleration is smooth, because obviously your motors can't go from zero force provided to like full force provided. Um, well, yeah, so there's a little bit of like a ramp up, I think. And your robot can't like immediately start moving and immediately stop. So it just takes into account all of that based on the physical constraints of your bot. So like where the wheels are and where the mass is distributed, and just calculates all of that, and it's tuned specifically to your robot. So it's super accurate and also handles all the tracking. So we recently last year we installed dead wheels on our robot. And that also made it more accurate. So it's able to tell our position on the field super accurately. So overall, it's made our auto so much easier. We're able to do so much more complicated movements during autonomous because we just tell it where we want to go, and it handles all the aspects of getting us there in the also the most efficient way possible, right? So mostly we've just been like using the default like path planner, but we're also thinking of going into pure pursuit because we've heard that's worked for a lot of other teams. I think it's slightly fast. So yeah. Go ahead, you can unmute. I don't know if you meant to raise your hand there.
Okay, I just what's your opinion on pinpoint with Limelight? Not Limelight, with Roadrunner localization.
Like the
Opinion on what localization?
screw.
So just so our team this year is using like pinpoint odometry. So what's your opinion on that? Like, do you think it's good, basically?
One second. So that's in like the IMU, right? From GoBuilder.
Yeah, it is.
Oh, okay. So we haven't used like sensor fusion with like an IMU before. We're actually going to like start doing it this year. So yeah. I wouldn't like be able to speak from experience, but it does seem like super interesting. We like bought our own like IMU, and we were also going to try to do that, but we haven't like done it before.
Yeah.
So you guys have already used like dead wheels and stuff.
Yeah, we did that last year, and that
Yeah,
worked.
okay.
That works like decently well, but we had some issues. Like we were off by like an inch or 2 inches at times. So we're trying to
Yeah.
try something new this year.
Okay. Yeah, we have also been like sometimes off by like up to an inch, but it's worked mostly well enough. But yeah, we thought we could also get a little bit better with using the IMU. So we were thinking of trying that this year. So maybe like a little bit later in the season, we'll let you know how that goes.
Okay, cool.
Okay. So yeah. Oh, and something about the encoders for the dead wheels is I don't remember exactly where I heard this, but I saw it in one of the Roadrunner forums that there are. It was like actually not even on the Roadrunner forum. I believe it was some article that someone in the community posted, saying that the different ports on the control hub and the expansion hub have different refresh rates. So I believe the first and last ports 0 and 3 on each hub is wired more directly to the controller, so it's refreshed more quickly. Whereas ports 1 and 2 on the middle 2 ports on the control and expansion hubs has some sort of intermediate step or something. I think like they might be hold less frequently. So if you like mix between ports like the 2 end ports and the 2 middle ports, you might get some sort of drift. We haven't like personally experienced this, but we've always just used the 2 end ports 0 and 3 just to be safe. So yeah, not something from our own experience, but something we've heard. So something that you should keep in mind if you're experiencing some sort of issues with dead wheels. Roadrunner has also helped us not just in autonomous, but also in like teleop. So it's made not that implementing headless is very complicated. It's pretty simple. But with Roadrunner, you can do it with just one line, just because of all the linear algebra utilities it comes with, right? You can just take a vector and just rotate it. So that's super nice. And also just in general in our code, we've found the Roadrunner utilities for math and linear algebra and stuff pretty useful. Something that we made in order to help us build the Roadrunner paths is a little extra page on FTC Dash. So what we found was that typing out the Roadrunner paths by hand was a little bit slow, especially when we were trying to prototype and we wasn't sure exactly what we need to do. Like closer to our competition, when we're just fine-tuning things, we want to be able to change every decimal point and get complete control over the code. But when we're just prototyping out the general paths we want to go on, it would be better to have some sort of visual editor where you can just click the point on the field where you'd want it to go, instead of typing out, trying to imagine a coordinate grid on the field and figuring out exactly which point. So we made this a few years ago, I think like 2 or 3 years ago, where it's just an extra page on FTC Dash. And then there's the field, and you can like click on points on the field and just add points to your Roadrunner path, and you can control like whether you want it to be a spline or a straight line or like a line 2, and then you can change whether you want the heading to be like tangent or independent. So you can put a start heading and end heading and make it interpolate between those two. So most, oh yeah, what?
Oh yeah, so we've have you guys heard of Meet before?
Yeah,
Basically the same
as
thing.
well.
I mean, this seems to be, so you're saying that you could draw the path inside of FTC dashboard and it'll be converted to code, or do you have to write the code and it shows like on the display like what your code does?
So when we like draw it on FTC Dash, what it does is it sends it as a list to the the code running on the robot, and then that code running on the robot just loops through every element of the list and then makes a Roadrunner path. So it's actually all open source. So let me go to GitHub and actually show you where you can find it if you're interested. Okay. Seems like GitHub has rate limited me. That is very interesting. I'm not sure what is going on here, but it seems that I've exceeded some sort of rate limit. So we're gonna come back to this a little later. Not really sure what's going on there, but yeah. So it doesn't actually convert it into code. but it'll give you like all the numbers, and you can just pretty easily like type that out. Honestly, actually, it wouldn't even be that hard to turn it into code. You would just interpolate the values into like strings. So we could really easily actually add that feature. But right now we just like give it to you like as JSON or something. I believe there's like a download button there. So yeah. And it's all open source. So if you want to like make a PR and add that, that would be very much appreciated. I did make a PR with the like FTC dash like main repo. But they said that they like the idea, but they just want to see a few changes. And that I haven't had time to like work on that recently. But yeah, so maybe one day we're gonna finish getting that merged. Let's see. So yeah, this is the link. Let me try it again, see if I'm still rate limited by GitHub. Okay. Yeah. Okay, rate limit is over. So yeah. If I go to where team code, yeah. Oh, wait. Actually, somewhere else. One second. Okay. I'm gonna share our actual code base. So let's see, send something else. Okay. There's a few red underlines, but don't worry about those. It's just like some imports that are missing, I think. Anyway, so what we have is we have this dashboard like path annotation. And so what that will do is FC dashboard, we'll change modify it. So it will look for that annotation, and then any classes with that annotation, it will add the a list of like path segments. Basically all the data that you entered into the web editor, it will be assigned to this variable called dashboard path. And then what we do is we just loop through each of the path segments, and then we just go through the trajectory sequence builder, and we just builder dot add each step, and at the end we run builder dot build, right? That's the way to do it, but we just generalized it. So we have an enum for every single type of segment, so like a weight segment, line segment, spline segment. We have each of those, and then we just each of the heading types, and then we just build that out. And then we return the trajectory, and then we follow that trajectory. So what you would do is you just run this op mode, and then you could easily prototype different ways of different paths through FTC Dash, and then you could just download it as like a JSON, and then easily turn it into something. So this is a little bit nicer than MeetMe, we think, because MeetMe, you just like write the code and then it gives you the visualization. Whereas with this, you can also interact with the visualization a little bit. So yeah, one way that it's not as good as MeetMe is that it doesn't actually like the visualization isn't in real time. You'd have to like run the code a little bit, and then it will show you visualization. So like you can draw out all the points and all of the parameters like the spline, but it won't actually show you the exact path, like the shape of the spline, until you actually run the code. So that's also a possible improvement that we can work on. But overall, it's been very helpful. Okay, back to this slideshow. So yeah, if you do want to use this, you just have to pull the code, sync Gradle, and then open it up in Android Studio, sync Gradle, publish to Maven local. So instead of pulling it down from the Maven repositories, we haven't like bothered publishing up there because as far as we're aware, no one else is really using this other than us currently. But if other people are using it, we will definitely publish it to the main Maven repositories. But you can just publish it to your local computer, and you can just import it from that local repository. So when you add to your dependencies, it's going to be the version number and then dash snapshot. Something else that we've done is since we're working in some pretty large teams, not like that large, but more than just like 1 or 2 people, we found it's pretty important that we're able to like know that the code works at any time. So like whenever someone pushes, GitHub is automatically going to run build on our code and make sure it actually builds, and then notify us if it doesn't. So most of the time we're going to be coding during our regular meetings. When we're with the robot, we can actually push the robot and see. But sometimes we also like code at home, and this is just nice to have. Even though you can build the code in your editor, it's better just to also double check that on the side of GitHub. So that's pretty useful. So on the right side is our GitHub action that we wrote to do this. It's a little bit more complicated than you might need, just because we're also building our custom dashboard. So we're also building FC dashboard, which includes a web server. So we also have to do a bunch of like web stuff with like React, like PNPM, you see. So yeah, that's why it's a little bit more complicated. Another thing that we did is made a custom initialization menu. So what we used to have to do a few years ago is we would change the code between every match. So for every autonomous, we would say, are we on the red side? Are we on the blue side? Are we going to start off on the left side or the right side? And then how much of a delay do we want? Which locations on the field do we want to go to? Do we want to score our preload or not? Everything would be controlled with like flags in the code, and we have to go in, change the code, and then re-push the code, and then redeploy everything, which was kind of a slow process, especially when we were trying to do like other stuff between matches. We were trying to like coordinate with our partners and maybe like fix up something that broke. So really cutting down on that time was super important to us. So what we decided to do is make a custom initialization menu. So according to the rules, you aren't allowed to touch the gamepad and like provide inputs to the robot during the autonomous, but before the autonomous, that's completely fine. So as long as you don't touch it after randomization, because after randomization, you might like give away like what the randomization is. Like you're not allowed to touch it. But before that, you can use the controllers in order to provide inputs to the robot. So what we did is we made this little menu system. So the carousel, as you can see, that's from when we had the ducks a few years ago with Great Frenzy. That was my freshman year, now a senior. So what we do is we use the D-pad to go like up and down and then cycle through each of the options. So our menu system like supports like numbers. So you can have like a number of milliseconds that your starting delay you want to be, so you don't crash into the other robot. So you can set like a minimum, a maximum, and then a step value. By default, steps to going to be like 1, but for like milliseconds, you want that to be like 250, so that'd be like a quarter second. That's I think a good amount of resolution that you can have. You can also set like no minimum and no maximum if you want it to be like that. And for stuff like alliance or in which side you're on, that is an enum, right? So it'll be like just a set of predefined values. So for alliance, it can be red or blue, and you just cycle through them. It'll just loop around, so you can do left or right. And there is also different conditions that you can set. So right now, next to do carousel. Oh yeah. So what's your question?
So yeah, this seems really cool, but like I'm just wondering if like how relevant this is going to be this season, because there's not really a lot of like changing factors other than like which alliance you're on. So I think what my team will do is just have two separate like autonomouses basically, and I feel like I'm not entirely sure how necessary this would be, but if you have any like if you think yeah, just like explain basically.
Yeah. So we actually made this a few years ago during Fright Frenzy. Just because the field was like so different. Like on each side. So that was like super useful back then. I agree it's less useful now, but I think it's still pretty nice. Just because if you're like go up to the field and you're on the field and your partner suddenly tells you, oh wait, our robot doesn't work anymore. Can you actually like score something on our side that we were initially planning to do there? You don't have to like change the code and redeploy or have a bunch of different autonomouses for every situation, because you're not just going to have red side and blue side, or you might have like other things like right. So was it you have like the basket on one side, you have like left and right side, and then you also have well, I guess that's pretty much it. There's actually not that much this season, but yeah. So if you have like 4 autonomouses, that pretty much covers everything. But we just didn't want to have 4 pieces of our code. Every time we change something, we'd have to change it in like 4 places. So that's why we made it like this. But I do agree that this year is not as helpful as it might have been in previous years. But yeah. So just another thing that it can do is you can also set up conditions where certain options can be invalid. So like next to do carousel, it says disabled because the year that we did this a few years ago, they had a carousel on the side next to the audience. So if you selected that you're starting on the side next to the audience, you can say whether or not to do the carousel. But if you're on the far side away from the audience, that was disabled. So we didn't actually end up programming an option to do the carousel from the side away from the audience. So we can also like disable that. So yeah. Another thing that we did is we made a custom event loop. So some of you that are familiar with like JavaScript would be aware of what an event loop does. But even outside of JavaScript, that's just where I'm personally the most familiar with it. So it's just like a queue of events, and each event has associated with it like a condition for like when it will be like ready. So we recreated this in Kotlin. It would have been very hard to do in Java, right? Because we wouldn't have had first class promises. I mean, not first class functions. So we wouldn't be able to pass a function into another function and keep track of all the actions that need to be done. But with Kotlin, we're able to like write a function for each of these steps, and then we're able to pass that into another function with like information about what it depends on. And then that other function has logic to know when all the prerequisites are met and it's ready to run. Then, okay, now you can run that function that's ready, and it'll be marked as done. Anything that depends on it will check and see if that's done, and so on. So, this was really cool. We probably could have used something like a finite state machine, but we wanted to do something a little bit more custom, just to have a little bit of fun with it. And most of the programs on our team were familiar with how promises work in JavaScript, so we thought it would be helpful to model it after that. So yeah. And it also helped us with our efficiency. So this is from a couple years ago when we had the cones power play. So what we had was we had 2 extensions, and they were operating independently. So one extension would drop our cone onto the pole, and one extension would pick up the cone, and it would have like grippers that would have like multiple servos on them that need to all coordinate. But both of them would try to expand out and do their action as quickly as possible. But the cone needed to drop before you could pick up the other cone. So there was a lot of complicated dependencies that need to be met before each action. There was like a complicated list of requirements of what other things need to be done first. And we found that this was a great way to, handle that. So this was the implementation that we used. It was actually not that hard to do. Just did a little bit of thinking about it. And I think I wrote all of this out in just one sitting in a few minutes. It didn't take too long. So, I mean, we're going to share the presentation, so you guys can look at this later. But basically, we just have, so in Kotlin, an object is basically like a singleton class. So you only have one of it ever. I think it even persists in between different runs of different op modes, but I'm not completely sure about that. So we just have a list of promises, and then as you add a promise, it'll just add it to the list, and it'll keep track of each promise has like an end condition for how you know that the promise has ended, like finished its task, and also which promises is dependent. So for example, we don't want to drop the cone until after our extension is fully extended, right? So yeah. So this is an example of us using it, and you can see the dot then and then bracket. The then keyword is inspired by JavaScript. Just it feels familiar to us. And then it's really just a function that takes in one argument, which is a function. So if any function takes in one function as an argument, then what you're able to do is you can just use the brackets right after it to make a lambda without having to actually call that function. So it's just very nice syntactically, very easy to write. And then one utility function that we wrote is like a multi-promise. So it's pretty bad naming, but basically there's a lot of situations where one action relies on multiple other things being done. So for example, here, when we move the arm position to the hopper position, we want both the vertical extension to be down and the cone to be secured. So that's like one example. Some other stuff that we've done is with OpenCV and April tags. We haven't done anything with Limelight yet, but we've done some pretty interesting stuff with OpenCV. We've been able to like track objects, like this cube from Fred Frenzy. Yeah, what's your question?
Oh no, I know.
So like have you guys been successful with color detection and stuff? Because actually my team, we were thinking of cycling the submersible in autonomous, and obviously you're gonna need like some pretty good like color detection and stuff. So we bought a Limelight camera, but like we've been struggling with the color detection aspect. So I was just wondering if you guys were like successful. Like I know you guys haven't really done Limelight a ton, but like for OpenCV is like color detection like, because there's also like variable lighting and stuff. So we're just worried like it's not going to be like consistent enough to be used in competition. So yeah, I was just wondering like how successful has that been for you guys?
Okay, can you just tell me a little bit about Limelight? I'm looking it up right now. But just,
so basically there's a web UI, and in there it's basically like essentially it's just the same as OpenCV, except it's a bit simpler because there's like a web UI. So you can tweak like the different like color amounts. And this is just for color detection. And you could basically so you filter out like different colors. But like the main issue is like when I was testing it is if there's like a different lighting environment, it like completely just doesn't work. Like I compared it with like two different lightings, and if you adjust the color for like only one lighting, and then you move to a darker area, it doesn't work at all. So that's like obviously a really big issue. So is there
Okay.
anything else?
So when you set the colors, do you use them in RGB or HSV? What color space do you use?
So for Limelight, it's HSV, I'm pretty sure.
Okay. Yeah, we use that as well. So does Limelight come with like an LED on it?
Oh no, it doesn't. I've seen people suggesting to put that on the Limelight. Actually, I haven't tested that, but that would probably putting like light strips on it.
Sure, because I don't know. The images I'm looking at seem to indicate that it has like an LED on it. So, like, actually, let me.
I'm using the 3A.
I think there's like what's your like low bound for saturation and volume?
Oh, I could try to check right now. I'd have to here. I could try to check, but
Yeah, and I think
Yeah,
like
so-
I don't know if the 3A, I don't know if the 3A has a lot like a light, but the
It
light
doesn't.
generally it's pretty dim anyway. So yeah.
Yeah, because if you increase the exposure by a ton, like the motion blur, it's really bad. Like if you move the camera at all, like the detections just completely go away. So you have to like lower the exposure by like a decent amount. So it's actually I've been like decently like successful with the yellow samples, but with the blue ones and like also the red ones, it's like pretty difficult because they don't really stand out as much. And it's just like I've been told to just get like a normal camera instead of the Limelight because so Limelight resolution is also like it's like very
What is resolution?
I think the highest it's like 12 it's like 1200 by like 700 or something. It's something I don't remember off the top of my head.
Oh, yeah, like 720 by 1080. I think.
Yeah.
Yeah, okay. That would be like
Yeah.
standard resolution. Yeah. So we have like I think a 4K camera. We just like bought because you can use any USB webcam, right? So we just like bought stuff off Amazon. We have like an ultra wide one for like when we want to see like the custom element. There's like 3 positions, and those positions are relatively like far apart in terms of angle. So we bought an ultra wide camera for that, and then we also have just like also like other like high resolution cameras that we've been using.
I don't think for color detection you need that high resolution. Like last year we were using like 300 something by 300 something. So you don't need that high resolution for color detection.
Yeah, I'm not saying that you need that. I'm just saying that you could get it if you like wanted.
Yeah.
There's no really limit. But yeah, so I would recommend that you maybe get like some lights next to your camera because that will just help mitigate the uncertainty in lighting. But I don't have any specific limelight advice, but I know that like the samples, right, are only like 3 colors. They're like red, yellow, or blue, which is very different color than the gray of the field or the submersible. So I don't know. Can't you just like increase the range of accepted values, or does that not work for you?
So basically like the way it works is that Limelight like it automatically creates a bounding box, which is it's very convenient because like I don't know how to do that. And then basically it gives you like values of like how like far away the object is relative to the middle of your screen. So the issue with like increasing the range is that if I increase it, the bounding box gets less like consistent. And like with that, it comes like the values of like where the object is located. So if I were to like add functionality for color detection, I would need like something very consistent.
Yeah. Okay. So that's part of the reason why we use like OpenCV. We're not super great at OpenCV, but one of the things that we've been working on implementing is we have.
Nash, are you still there?
Yeah, he's frozen on my screen.
Yeah, his sound cut out too. Type in the chat if you can hear us, Nash. Hey, there you are.
Hello.
We lost you for a minute there. It like got all locked up.
Can you hear me?
Yeah, we could hear and see you before. The camera just went off again.
Yeah, I think my internet connection's pretty bad, so I just turned it off. So hopefully that
Yeah,
will.
all right. Give it a try. You got to share again though.
Yeah. Oh, okay. Right. Um, w- when did I cut off? Like, I don't remember what I was saying. Like how much of that you heard.
Something about OpenCV.
Um, do you remember like specifically what part? Okay. So I think probably the part I cut off was I was talking about like the custom stuff we were doing. So did I?
You cut off around when you said like we aren't the best with OpenCV. That's like about where you cut off. Like those words exactly.
Hello?
Yeah.
Oh, okay. It just said my internet connection went out, and then it reloaded the page. And now I'm back. Okay. This might be a little bit difficult if that keeps happening, but anyway. So what we've been working on is what you're saying, object detection, but it's a little bit better when you have like all of the power of OpenCV, because you know some information about your object that MineLight doesn't. So what we've been trying to do is we start with the same step where we have a minimum and like maximum like color thresholds and like saturation thresholds and stuff, and we apply those filters to all the pixels in our image from each frame of the video. And then looking at that, we have all the pixels that pass the filter. And then we use like, I think like erode and dilate, I think are the functions. And we use that to kind of get rid of any just random pixels from the noise that might be in our webcam. Any pixels that, you know, just might pass the threshold by chance. So we do that a little bit. And then what we're left with is only the large objects of pixels that match that threshold. But there'll be a little bit like fuzzy around the edges. Yeah, what's your question?
So using this like color detection, like thresholding, would it be like theoretically possible to get like the orientation of an object? So for example, like in the season, like the samples, would you be able to like I guess like in degrees maybe be able to figure out which like way the object's facing? Because our robot has a claw that can rotate sort of. So it'd probably be better to have like the robot move onto the sample then rotate based off of color detection. So is that possible with OpenCV?
Yeah, I mean, like anything's possible. I'm pretty sure Limelight is probably like right with OpenCV because it's just the industry standard, like
Right.
image processing stuff. So like anything's possible, but you just take like a lot of math, you know. So like we haven't done that yet, but it is on our roadmap of our goals for the season is writing that code. Yeah.
So are you guys going to like cycle the submersible in autonomous? Is that like
If
the end
possible,
goal?
yeah. I mean,
Okay.
that is obviously, you know, if everything goes well, yes, but we'll see how that goes. Yeah.
Okay.
That is our plan as of now. Yeah. So the sort of so in OpenCV, what you have are these pipelines based on steps of processing. So what we've been trying to do is first, you know, get all the pixels that match that filter in terms of color, and then we just sort of get rid of any noise, any stray pixels using the erode and dilate steps. And then what we do is we want to smooth out the edges So, we have all these blobs of like pixels that match our filter. But we want to turn it into like a polygon. And then based on that polygon, we can, it's much easier to work with than just a list of, which points, like just a random amorphous shape. If we turn it into some sort of polygon, then we can easily estimate like the size of it, and based on that, how far away it is and the angle of the rotation. So what we discovered, we just like did a little bit of research into different algorithms that we can use for like turning a bunch of points into a polygon. And what we came across was well, first, what you need to do is turn it into contours. So take all your pixels, and then there's an OpenCV methods for finding contours. So that'll just give you all the points on the edge of the shape. And then what you want to take is take those edges and turn it into a polygon. And the way that we found would, what algorithm that we found that would do that is the Douglas Perker-Ramsey algorithm. I mentioned that on our slides. No, I don't think I talked about this on the slides. Okay. Well, just from memory, I believe it was called the Douglas Perker-Ramsey algorithm. And what it does is it just takes like the points and it looks at the angle that they're going at, and then looks at each next point in the contour and see if it's basically going in the same angle. And then it just extends that line until it gets to a very sharp corner. And then it marks that as a vertex, like a corner, and then it keeps going across that. So you can do a little bit of tuning with that and turn it into a polygon. And then based on that, you can tell based on the size how far away it is and also the angle and stuff. So that's kind of our plan of what we're planning to do for this season right now. Yeah, what's your question?
So is there like a quick start of like what you just described using like Easy Open FTC or like CV? Like, is there like a quick start out there that I could like start off on, or do I have to like?
So you've heard of Easy OpenCV, right?
Yeah.
So that's what we used to use. It's actually built in to the FTC SDK right now. So you don't need to like install everything. It's already all part of it.
Oh, okay. So like which like classes and stuff would I need?
So we still use Easy OpenCV, even though it's been built into the SDK, just because we never bothered on transitioning it. I mean, it's the same functions either way. So yeah, I'm not super sure what the exact like imports would need to be. But the FTC SDK of course has these example functions, right? If you just go into I forgot what the folder is called, but it's like FTC robot controller, and then if you go into like I think like internal and external, they have like samples, right? So I believe there should be a couple of samples for how to do the
How do you know
visualization
which
stuff.
side is 1 and which side is 0?
We don't.
Okay, got it.
Yeah, and then Easy OpenCV also has their own pipeline examples. So we started off with that with like the color filters, and then we just like added our own stages to the pipeline and just progressed from there. And it's a little bit hard to like find exactly which OpenCV functions you have available to you, and like exactly how they work and what they do. The documentation I found is a little bit lacking. Let me just share my screen again. Yeah, so I found that the documentation is a little lacking. Most of the documentation that exists online is for the C version of the library and the C++ versions. So like, I think it's just C++, but those have the most documentation. So what I've had to do is read the C++ documentation and like reverse engineer based on that how the Java library works. So yeah, the Java documentation is not super great. And another very useful tool that we had was the Easy OpenCV simulator. So it takes a lot of work in order to get an accurate pipeline going, and a lot of time outside of meetings. So what the Easy OpenCV simulator does is it lets you test out your code at home without the robot, without the control hub. All you have to do is run the simulator on your computer and like have your webcam you should use the same webcam that's on your robot, right? But it's easier to take the webcam home than the whole robot. And then you can just set it up and have it like practice detecting stuff and tuning the pipeline. So that's been super helpful. So yeah, it's just Delta CV EOCV sim, right? This link. And slideshow is going to be posted. But if you just go there, you can download it. It's a Java app that you run on your computer, and you just give it your pipeline, and it will let you test it out. You can test it out on pre-recorded videos, any image you have on your computer, or a webcam, with a live feed. And that way, while your build team is building your robot at the meeting, you can also test it. Or when you go home later without the robot, you can also keep testing your pipelines. Also, April tags. I'm sure you're familiar with them, but of course they're super useful, just for like finding stuff. So this is still kind of a work in progress, but we're working on integrating C++ into our code base. We think it would be helpful for some sort of especially resource intensive operations. Specifically, if we want to like maybe do some sort of custom image processing algorithm that isn't in OpenCV, right? We don't want to write that in Java, looping through every number in every pixel of like a huge matrix. If we do that in C++, it'll be so much more efficient and performant. So we've done this so far by using the JNI, which is the Java native interface. So it allows us to talk to native code. And yeah, so it was a little confusing at first, but I like followed along with some like tutorials online, and it actually wasn't too bad. So yeah, basically the only I had to add a few lines of code. If you're using Java, this should be all the steps. I mean, if you're using Kotlin, these are the steps that we had to use, but Java should be also extremely easy. Java is actually the default like that most people use, more popular than Kotlin. So it should be even easier for you to find resources like little tutorials on how to do it. So you just add these bits of code into your code base, and in your editor, you want to go into the like settings, and you want to install the NDK, which is the native development kit. So that you'll find that in the SDK manager section of the settings page, and you have to also have CMake installed on your computer. And CMake is just what compiles the C code, and then the NDK is what allows your Java or Kotlin code to interface with that compiled C code. So here on the bottom right, we just have an example of like some C code that you might write. So you just need to also include some additional information so that the C code knows like what kind of like that it's part of Java, right? So you need to say you need to include the JNI header file, and then this just basically returns a string that just says hello from JNI. That's like our little hello world example. And then there's just some build files, and then in your Kotlin, this is Kotlin. In your Kotlin, you use an external function. So just declare that, and you can call that anywhere in your code. And then in your companion object, you just want to load the library with system.load library, and then in your CMake list.txt, you need to include the list of all the files, the C files that you want to compile. So that's really all the steps you need to take, and then you have C++. Okay. So another cool thing that we did was we wrote a custom I2C driver. This allowed us to interface with a sensor that we were using that wasn't supported by the FTC SDK. Since then, the SDK, I believe, has added support for the ultrasonic sensor. So we don't actually need this anymore. I believe they added it this season. We just haven't gotten rid of it from our code base yet, but we were probably just going to use the one that's built in, just to avoid any bugs that we might have encountered while we made ours. But it was definitely a very great learning experience. And we were able to like find some resources online, especially from Photon FTC. I believe they also make a bunch of like custom drivers. So that was a good reference on how like ITC like works and stuff. So yeah, we just took apart a cable from like Rev, the sensor cable, and we soldered it to each of the pads, and we wrote this little I2C stuff. This is just the get distance function. Pretty much the rest of it was just like boilerplate. You just have to add a custom annotation so it shows up when you are doing the configs. Okay. I guess something else that I'd like to show is, speaking of configs, our team used to do the configs through the what's that called? The driver hub. Just like is recommended, so you go into the settings of the driver hub and you type out each of the motors and then all that. But we found that we prefer to do it through the code. So let's see, is that working? Okay. So this is an XML file. So what it has is, our webcams. It has, all our motors, our servos, and so on. This is how this information is stored when you do the configs, in the file system. So you don't have to do it through the driver hub. You can also declare it in your code. And we found that that's a little bit nicer because you can version control it, you can track it, you can control, copy and paste it, and like easily change it. We had an issue once where our config just mysteriously disappeared. I don't know what happened. It just got deleted. And then, we didn't have any backups. We couldn't like save it or do anything. So we just had to retype the whole thing out, and it actually wasted not a crazy amount of time, but it was just really annoying. So from then on, we decided, just put it in the code. It's a little bit annoying that the build team can't change like the ports on their own. They have to like talk to the code, and we have to do it for them. But I think it's also well worth it in the added safety that we have. So all you have to do is create a file in team code source main res xml config.xml. So yeah, and then in that file you just put all of your motor names and such, and all your configs. And I guess the last thing I'd like to touch on would be some of the website tools that we've made for our team. Let me send this actually. Okay, so we made our custom inventory tracking system. So what we have is we have a scraper that goes through all of the pages on revrobotics.org, all the pages on GoBuild and AnyMark, and it just compiles all of them into our own database, and we can search through it super easily, see the pictures, how much it costs, how many are available for us. Some of the APIs at like Rev and GoBuild actually also expose how much they have in stock at so you don't order more than they have in stock. But we can also like see that and see if they're close to running out, we need to order it quickly. Or if they have a bunch in stock, we can wait a little bit, even though it's not exposed on their actual website. And then we can allocate for different projects that we're working on. So we have a varsity and a JV team. So we can also allocate parts to our varsity team or to our JV team or to our outreach robot or mark it as broken. And we can really like categorize all our parts or mark it as available to use on a robot. So we can keep track of all the parts that we have super easily. So yeah. And it also has like a user management system. So we have like admins who can like add new users and remove users. We have people who can manage parts who can like update like inventory counts. And we have people who can just like read the stuff. So it's pretty fully featured. So and it also supports multiple teams natively. So like we built it from the ground up to work with any team. We can set you up with it pretty quickly. Pretty easily if anyone is interested. And yeah, it also supports mobile, so you can use it just fine on your phone. While you're building your robot, just have your phone next to you and you can do it. Or you can, if you want to do it from like an ultra-wide monitor, it also works great in that. We also have a scouting system that you can use. So let me change this email. Great. But yeah, so I changed it to my email because Joe isn't super involved with the scouting anymore. But so this scouting system lets us track easily all the other teams that we meet at a competition and categorize each of their like capabilities and determine who we want to work with. We used to do this with like paper or like spreadsheets, which wasn't like as powerful as we wanted. So this way, everyone just walks around with their phone and then they just ask the questions, type the response into their phone, and then their game master, who's responsible for like strategy, will look through all the responses, and we have a bunch of like powerful tools that they can use in order to determine which team would be the best fit to work with us. And teams will like self-report what scores they got. We can also put in like what they actually scored during competition and use that also in our analysis and our decisions, right? Because some teams will like exaggerate when we just ask them. So yeah. And this also supports multiple teams using it. So we can have our scouting data and your scouting data will be completely separate. So, multiple teams can also use it. So if you want to use it as well, let us know. We've also, used our coding knowledge extensively in outreach. We built like chemistry tools for our chemistry department that they used to teach with, and a bunch of other stuff. And a bunch of other websites like mapping software for a school for students to get around and stuff like that. So we've used Next.js. It's very nice. And Tailwind for styling. And MongoDB has a very nice free tier. But we're also looking into like SQL databases now, as we like, SQL databases are a little bit better for like large projects, but MongoDB does have a very, very nice free tier. So that's why we are using it. Of course, TypeScript helps us avoid like silly mistakes, and Git, you guys are probably all aware of that. We use TRPC also, but Next.js server actions have mostly like replaced that for us now, because they, have type safety between front and back end. But TRPC is nice also. So yeah, that's pretty much all the stuff that we had to say. If you have anything specific that you'd like me to talk about, you can ask about it now. Yeah. Go ahead.
So my team wants to learn like a bit more about like PIDF, like control loops and stuff. Because currently we're just using like the P in PIDF. So we're wondering if like a more complicated control loop would be like beneficial.
Yeah, I think it would definitely be beneficial. How familiar are you with PIDF? Like how much do you know about it?
So currently not like a lot actually. like our loops are like basically like the most simple version. So we're just finding the error and then just setting the power to the error times the KP, basically.
Yeah. So like PIDF isn't actually like very hard to program in like itself. I'm sure you can like just find some snippet online. There's so many people, like so many tutorials on how to code it. But yes, the P stands for proportional, the I stands for like integral, like over time, and D stands for derivative, like how fast it's changing. And the F, I'm not actually sure what it stands for, to be honest. But like you could just do PID and be fine. You'd also do PIDF if you wanted. I think the hardest part is like tuning it, getting the constants. And I think I've read that there's no like mathematically correct way to tune it. It's not like a solved problem. You just kind of have to know, like guess and like check and just do your best. There's no like algorithm to find optimal PID constants. So yeah. There's actually Joe on our team is usually the person who tunes it, and I think he's just mostly gotten a feel for it. But yeah, I not really. I don't usually do the tuning for PIDF for our team. So yeah, I don't really have too much to say about that.
Would you mind if I like send in the chat something we use within our team to like teach about PID controllers?
Yeah. Okay. Yeah. Yeah. Sure.
Um,
That'd be good.
Okay, also, so I think we're gonna need a different like KP coefficient for every single motor, right? Because there's like different like weights on the different motors.
Yeah. Yeah. That's true. Yeah. You're gonna need different coefficients for every single PIDF that you do. You're
Okay,
gonna
and you have
tune them
to
individually.
tune every single one. Okay.
Yeah.
Okay. How should I like organize that in the code? Like how do I make that like not like sloppy and stuff? Like how would I guess I could probably figure it out, but
So the way that we organize a lot of our stuff is we like to use enums. So what we do is we have like an enum for like okay. So like we would have like arm coefficients as an enum, and then each of the inside the enum we can set like p equals 0.1, I equals like 0.5, and so on. And when you access it, you would access it like PIDF coefficients dot this like dot p, and it'll give you that value. I think.
oh,
Right.
okay, got it. And also, my team members asking like, what are the benefits to including like the I coefficient and D and F coefficient as to just having the P coefficient?
So
We had
if
that.
you just have the p coefficient, right, you're gonna like overshoot, and you're just gonna end up like oscillating back and forth. Yeah, oscillating is the right word, right? So
Yeah.
So the p, if you're like far away, it'll accelerate you super fast. But as you get closer and closer, the d coefficient will like check if you're going to overshoot, and then yeah. So I think the d coefficient checks if you're going to overshoot and then slows you down so you actually like end on the point itself rather than overshooting and then turning back and then oscillating back and forth. And then also if you're just slightly off from the target, right? Sometimes there's like some sort of like activation energy almost. Like if you have such a low power on your motor, it's not going to move at all, right? So if you're just slightly off, then sometimes you just need to have a little bit of a higher power just for a moment to get you right on the place you want to be, and then you can do it. So that's what the I is for. If you're slightly off for a long time, then you think maybe I'm not providing enough power. I need to increase the power. So because I've been off by this amount and it's not getting any better, so I need to increase the power. So I is like integral. It like integrates over time. If you're familiar with this. Yeah.
Yeah. So actually, yeah, I've experienced that a lot. Like the motor position is like one tick off.
Yeah. So
okay.
If you're familiar with calculus, derivative is rate of change, and integral is like something over time. So
okay,
it kind of makes sense once you understand it like that. Let's see. Do you have any other questions?
Oh yeah, I was also looking. I was looking at the SDK also about like the color detection stuff. So is it well, you wouldn't know off the top of your head, but let me see. So is it like, let me try to find it again. Hold on. So is it color vision color locator? Is that like, so it's like it's using something called color blob locator processor. Is that something you're familiar with?
I don't think I used the like examples that were in here because we did
Okay.
ours before they added these examples in here. Right? These are pretty new.
Right.
So I'm not super familiar. Let me see if I can find that.
So I think this is basically what you're talking about. Like, so this like it defines like a range for like the colors, and
Yeah,
then
that sounds right. Yeah.
it sets like the camera resolution, like the camera parameters and stuff. So
yeah.
okay. So is there a way, because in like the Limelight web UI, like you could also tweak there's like the value and like saturation and all that stuff. I don't see that here. So how would you do that?
Let me see. So I believe the function you use is core.inRange. And it will like take like an image and it would like check that all of the right. So well the way that OpenCV works is each image is like a matrix of pixels, and then there are also channels. So each pixel has 3 channels, right? If it's an RGB image, those channels would be R, G, and V. If it's an HSV image, those channels would be hue, saturation, value, or like brightness or whatever, or lightness. I don't know. Anyway, so those 3 channels are just 3 like sets of numbers. So it doesn't like matter if you're doing HSV or RGB. All you're doing is you're saying there's a minimum number for channel number 1 or a maximum number for like channel number 2, right? So you just like set the numbers. And then HSV or RGB is like your interpretation of the numbers. But to OpenCV, it's just a set of numbers. Does that make sense?
Yeah. Okay,
Yeah.
I'll look
It's
into
not
that.
different for RGB or HSV, right? You would need to convert the image from RGB to HSV first, but then you can do the same operations. But just keep in mind that the numbers you're operating on represent something different, but they still are stored the same way in the underlying data format. Any other questions?
Wait, also I'm trying to use like the easy open CV simulator. So I downloaded it. Do I just like run it off of I just run it using like the Java like platform binary?
I think so.
Yeah, because I looked at the instructions and it just said to just run it on your computer. Oh yeah, it works.
Yeah, you just run it. Yeah.
So do you
Are you
like
getting any errors or something? Is it working?
no, yeah, it's working. So I'm assuming you just so would this like work off? So you plug the camera in and it's gonna feed like the video into the computer, right?
Yeah.
Okay. And then do you just download your pipeline and just upload it to like the app?
You don't just like upload it. Like in the app, there's like a file picker, and you just like choose the file that your pick comes in, and then it will visit the app. If you have any other questions in the future, you guys can email us, and we can maybe if there's a lot of stuff that you guys have questions about, we could even like do some sort of meeting again in the future. Any final questions?
No, not really. I think
Okay.
I'll look into the stuff you guys are talking about.
Okay,
Yeah, I
cool.
think you guys have some really
thank you.
interesting stuff.
Thanks so much for coming, guys.